China and to the south of Japan, this rain band here, there's more rainfall in winter time associated with conventional El Niños. However, over southern part of the Western Pacific, there's dry conditions. So maybe have impact to Thailand, but not so much. The significant rainfall decrease is over Philippine area and the southern part of South China Sea regions. However, for El Niño Modoki, these dry conditions is weakened much. Okay, it's dry conditions. And also a little shift to north. So you can find that this rain band disappear, okay, over here. So why this happened? Okay, this also shows a composite study. So if you mix all the El Niño case, then you got dry conditions over the whole tropical Western Pacific, also Southeast Asia regions. If you divide into the conventional El Niños, you'll find that this dry condition enhanced with a strong rain band here appears. However, for El Modoki, this dry condition is weakened. Okay, these are differences. So why this happened? We first take a look at the large-scale circulation over tropical regions. This is from the divergent winds and the velocity potential, and this is OIRR. And actually, this shows that this dry conditions is associated with strong downward motions over tropical Western Pacific. In El Niño Modoki, this downward motion is weakened much. And then we further check the large-scale circulation over tropical Western Pacific, found that there's a strong anticyclone anomalies associated with conventional El Niño. However, for El Niño Modoki, it's anticyclone, but much weakened, and also shift to north. So that this anticyclone may be induced by the strong downward motion because in the lower troposphere there's a divergence of the air. Then there's anticyclone anomalies over here. And for this one, it's weakened, it's an anticyclone here. And we further use a simple baroclinic model, which is a dry AGCM from GFDR. So I will skip these details. And we did 2 experiments. So with this model, with forcing from the associated with El Niño, different kind of El Niños with heating anomalies appear in the tropical Western Pacific. Then you get the response of the atmospheric circulation, which is very close to the observations. And the second experiment, we only retained this cooling, also associated with conventional El Niño and El Niño Modoki. You can find the forced response is nearly the same in tropical Western Pacific regions. That means this anticyclone or strong downward motions is actually forced by the strong cooling over tropical Western Pacific, which is closely associated with conventional El Niño. And this is there's a weakened cooling, which is associated with El Niño Modoki, and they forced a weaker downward motion and also an anticyclone over here. So third part, our shift to a new perspectives from the CME-5 simulations on the East Asian winter monsoon. Okay, this CME-5 is a couple model intercomparison project phase 5. So before we had CME-3. And this also will be used for the IPCC 5th assessment report, we call AR5. And here we use a result from the 18 models with the simulations of a historical period. Okay, it's from 1979 to 1998. And firstly, we have a look at the climate knowledge over East Asia. Okay, this is from the observation, from the analysis. And this is 18 models ensemble mean. So it shows sea level pressure and wind over 850 hectopascal. And shading shows surface air temperatures. Okay, so that's a model can capture where this climate technology over East Asia regions. Okay, this Siberian high and Arctic low, and also the wind, a northerly wind here, and turn to South China Sea with a cold temperature extended to a lower latitude in East Asia regions, shows the cold air activities. And this is the upper levels of the atmospheric circulation, such as the shading shows a jet, and the contour shows East Asian trough over mid of troposphere. So generally, they also capture where the East Asia trough and this jet. And maybe the model have a little weaker trough, okay, but not so bad for the climate knowledge. And this shows a Taylor diagram. Actually, look at these figures. If they confine this region, that shows the model have a good performance in simulated the East Asia winter monsoon. So here, that shows for the SLP and the surface air temperatures. The CMP5 can simulate where over East Asia regions. Okay, we choose this region to represent East Asia. However, there is a little large bias for the precipitation over East Asia regions. And also for the upper troposphere atmosphere circulation, you can find that the model can simulated the East Asian trough, which means the potential height over 500 millibar, and also the jet, okay, but have a little larger bias for the wind. It's a meridional wind over East Asia. That means the northerly wind. Okay, and then we separate the East Asia variability into the annual time scale. That is next 8 years, and we have a look at the variability, which is standard deviations. Okay, here it shows the reanalysis data, and this is a composite ensemble mean. That means for different model. We find that for the interannual time scale variations, the model can simulate here where compared to the observations. So if we choose a observation winter monsoon index, which is defined by Yang recently, you can find for this standard deviation, the models is close to this one, a little nicer than the observation, but not bad for this simulation. However, if you look at the interdecadal time scales, which is longer than 9 years old, then you can find this model simulations is much weaker than the observations. That means the model cannot very well simulate the variability of the East Asian winter monsoon on interdecadal time scales. And for this winter monsoon index, you can find that this standard deviation is much lower than the observations. However, if we look at the trends, long-term trends of the interdecadal changes, this index, there's many index actually. We here only shows that which is my index in 2000. And you can find that this is a normalized index. The model, okay, this red line shows consistent with a long-term trend for the winter monsoon variability. So it's a little nascent also, but actually shows weakened around this 1987. So, and however, for recent years, if you look at the Arctic oscillation variability, you can see that this variability, some years, they turn into a negative phase. And also in China, in recent years, such as 2005, 2009 to 10, we got a very strong winter monsoon with heavy snowfall in China. One story is about this year, because this year in China there's a continuous 70 warm winter. So in this year, our National Climate Center also predicted that there should be a warm winter in this year. However, this year is very cold in whole China and very strong heavy snows. So maybe from this year, there's some shift of the winter monsoon. But we don't know much about these interdecadal changes. And we know for the CME5 simulations, there's a decadal hindcasts and predictions, so which is can predict until 2035 years, which is a decadal predictions. So since the model can simulate this kind of interdecadal trends, we may use this result to estimate near-term changes of east wind monsoon, which is not only important to the East Asia regions, but also may be important to the tropic regions, include Thailand. And so finally, I'll give a brief summary. And so the first is climate models in CME5 shows ability in simulating east wind monsoon variability with interdecadal change, which is close to observations. I mean the timing. So this interdecadal change. However, the variance of the East Asian winter monsoon intensity are small, especially on interdecadal time scale compared to the observed. And so the question is, what's the causes for the small variance in the climate model simulations? So far, we don't know the reasons, which we may use this CME5 to investigate these causes in the future. Second, East Asia winter monsoon experienced a significant weakening after mid-1980s, so which is leading to a regional warming and less frequent cold waves. And the Arctic oscillation and associated planet-scale wave activity are suggested to be responsible for this weakening. So the question is that where the East Asia winter monsoon shifted strong regime in recent years. So this, I also mentioned that this may have important implications for the tropical regions precipitation also. And third is two Pacific warming events have different impacts on winter climate anomaly in East Asia and Southeast Asia. For the El Niños, wet conditions over South China, but dry conditions over southern South China Sea and most of the tropical Western Pacific. For the El Niño motokin, it's weakened dry conditions around the Philippines with a little northward movement. So the question is, how do these two Pacific warming events interact with Asia, Australian monsoon? I mean, for these two kinds of warming events, such as for the East Asia winter monsoon, these warming events can impact the East winter monsoon. And we know this East Asia winter monsoon may influence the tropical region and even to the Australia summer monsoon. However, the warming events may have a direct impact on the Australian monsoon. So how to combine this interaction together is future issues which can be related. This also maybe with Southeast Asia monsoon. And also, we mentioned that global warming may have a significant impact of the air-sea interaction over Pacific regions, such as this cause a different kind of Pacific warming. we may investigate does global warming play a role in this